Hey everyone. Well, everyone's logged on. Welcome. I'm sending emails out to the other class. That should be everyone. And we have our first viewer. Looks good. Stream's up and going. Sorry I ran a little late today. Usually I get up here, pose. It wants me to pose for a photo before every single one of these. So I posed. It took like 3 minutes for it to snap that little thumbnail pose of mine. Anyway, it's 3:46. Guess we're just a minute late. I finished that last class, and I think in record time. We were done well before even an hour was finished. The activity is fairly short. I kind of like that we got it done before exam 4. I think in the past it was the one that we started with immediately after exam 4, and people were often a little burnt out and looking forward to finals week. So anyway, we got through it easily and quickly today. So we'll talk about that in just a minute. Coming up this week, there's a few things I want to make sure everyone knows. We will have some review times. Oops, let me get my new pen. Here it is. We'll have some review times coming up where you can chat with me here on YouTube. Of course, there's other times you can meet with me as well. Anytime if you have a few minutes, you want to spend some time with me online, I can work with you on Blackboard. But here's the big review sessions coming up for this week. We'll meet tomorrow at noon, and then we'll meet again Thursday morning at 11 a.m. Those are review sessions for exam number 4, and exam number 4 is scheduled for Thursday during class. The exam is, I'd say, 70% written, and the 30% that isn't written is solidly in my brain. I know the type of questions I want to ask. It's just I have to get them written on the exam form. So I think I was able to transform the knowledge that I wanted you to be able to get into this new format. It's looking pretty good. It's certainly much less stressful than transforming exam 3 was, just because I know how the machinery works now. And one thing you will be required to use is the equation editor. I think there were 2 students in between the 2 classes that were unable to use that. There will be several times in this exam where I will want you to write down a definite integral that will describe a situation, and you certainly can't do that without that equation editor. So if you've been unsuccessful in making that equation editor work, talk to me, send me an email, I'll work with you online, and we'll make sure that everyone has access to it. It's going to be a big portion of the quiz we have coming up. Okay, so make sure you can do that. Other than that, I'm ready to send the class off to whatever you want us to talk about. Fill up the chat with questions for me, and I will do my best to answer those questions. And yes, by the way, there will be a quiz today. I will ask you to do 2 things. The first thing will be to set up the integral that finds an area between 2 curves. So I'll give you the equations of the 2 curves. They only meet in 2 points. There's just one single area. So the first part, I think 7 points, is I'll ask you to set up the definite integral that will find that. And then the last part, the last question, will be actually to calculate that area. Yeah, we can start with question 1. What a fine place to start. So that's today's quiz. Area between the two curves works just like the problems worked on the last one. So here we go. Question 1, we're given a Lorenz curve. And the Lorenz curve gives us the distribution of either income or wealth. So here it is, L of P. P is the proportion number. 0.3p plus 0.7 p to the fifth. And in part A, we're asked to find the Gini index. Well, the Gini index is the index that goes from 0, 0 up to 1, 1. It's the area between this curve, which is even distribution of either income or wealth, and the sort of a belly curve, which is described, which describes sort of what there actually is. So this is absolutely perfectly equally distributed. The bottom 20% of 20%, the bottom 50 of 50%, and then underneath that is the more typical situation where the bottom folks don't have as much as the top. I don't think there's a society in the world where there is equal distribution. And I know nothing about economics. I'm still trying to figure out how we ended up with all this stuff that makes so little sense to me and puts us in so many grave situations, but here we are. So we need to find this area between those two. The bigger the area, the higher the index, and the less equally distributed these incomes will be. So there's our Lorenz curve. The Gini index is double this area. Well, that curve, the top curve, is the equation y equals p or y equals x, depending on what you're using for your variable. I like p here because p is proportion, but some people like x. It doesn't really matter. So let's find that. Okay. So we're going to take the integral from here to here. That's 0% to 100%, 0 to 1. The area between the curves is the equation of the top, p, minus the equation of the bottom, 0.3p plus 0.07p to the fifth, followed with the dp. And it's certainly okay to put x's where all the p's are. And we need to multiply that by 2 to get the Gini index. If we don't, then the maximum would be 0.5 and the minimum would be 0. I like having that 2 in there, and so the authors of this index, that allows us to have a scale that's somewhere between 0 and 1. Well, before I start the antiderivative, let's make sure that we do the simplification. So we'll distribute through the set of parentheses first, p minus 0.3p. Oh, got that decimal point in the wrong spot, didn't I? Well, let's just, we'll have to distribute. We'll distribute that minus sign through, minus 0.7p to the fifth bp. And notice that those two are like terms. And since they're like terms, rather than having to do an antiderivative that has 3 terms, let's combine those through those two, 0.7p minus 0.7p to the fifth dp. It doesn't matter if you distribute the 2 through there, have that 1.4p minus 1.4p to the fifth, that would work. I'm going to keep it out front, I think, for right now. Again, it doesn't matter. It's just a constant multiplier. So let's do the area between the curve first and then double it. All right. Area between the curve, we take the antiderivative of the difference between those two functions. So 0.7, this is a power function, raise the power by 1, multiply by a half. Subtract off the same thing here, keep the 0.7 as a constant multiplier, keep the 7, raise the power, multiply by the reciprocal of the power. Evaluate this from 1 to 0. So set up the antiderivative, take the antiderivative, plug the bottom and the top numbers in. And of course, remember at the end of all this, we're going to multiply it by 2 times whatever all that comes out to be. Well, if you plug in a 1, I can do this one mentally. This is 0.7 times a half. That would be 0.35 times, times 1, okay? And this other one is, let's see, 7 divided by 6, that'd be 0.6 I think I can do that. I got a calculator here. I'll just do that. 7 divided by 6 is 0.117, I guess. I'm going to round on this. I'm doing this subtraction. This is a 0.2. Again, this is rounded. Maybe that's off a little bit. Let's multiply that by 2, and it's about a 0.466467 is what my answer key has. So depending on how you round that, if you're somewhere in the ballpark, that's going to be just fine. Okay, so there's the Gini index, about a 0.466. That's the wealth distribution, and that's a fairly small number for a wealth distribution. If you skip down to problem number 2, when you look to see how the wealth is distributed in the U.S., that's a way, way bigger number, even way back in '89, and it's getting bigger as we go through. So there it is, problem 4A. We found the Gini index the way we always find the Gini index. Equal distribution curve, Lorenz curve, find the area between those two. And on the exam, we're going to have 3 questions. One of them will be to find the Gini index. One of them will be to compare two Gini indices. So what's the higher number mean? What's the lower number mean? And then one where we have a Lorenz curve question. And the Lorenz curve question will be something like part B or part C. Now, the Lorenz curve itself does not give you the Gini index. It just gives you some information about certain percentages. So what proportion of the wealth at the bottom 80% of the population control? Well, 80% written as a decimal is 0.8. So that's the proportion of the population. We're going to calculate L of 0.8. And I want someone with a calculator to help me out here because I messed this up royally a little while ago. So someone with a calculator, get it out. Let's figure out what this is. 0.3 times 0.8. Again, I'm just putting this right in the Lorenz equation formula. Plus 0.7 times 0.8 to the 5th power. I think my calculator that I have on board isn't all that sophisticated. So do this calculation for me and tell me what you get there for L of 0.8. It's got to be some number between 0 and 1. And more than likely, it's quite a bit less than 0.8. So throw those numbers in the calculator, someone. Let me know what you get for this calculation. I'm going to start out writing what this means. And I forgot that 0.469. Thank you. It's been doubled. We're going to round that. The bottom 80% of the population controls about 47% of, and I forgot if this was income or wealth, so I'm going to go back and look. Wealth. So you put in a proportion, it spits out a proportion. And of course, that has to be less than that. There we go. There's part B. Now we're on to part C, and we're going to use this information. Here's what, I got a big population out here. The bottom, there's the bottom 80% right there. And here's the amount of wealth they control. If there's all the wealth, they have that bit right there. They have 47%. So it's a big portion of the population and a smaller piece of the pie. So if the bottom 80%, at least well off of the population, if the bottom 80% controls 47% of the wealth, what would we get for part C? How about the wealthier 20%? How much of the wealth, what proportion, I guess what percentage, I like working in percentage better. What percentage of the wealth did the top 20% control? I guess I asked for proportion, but in both cases, it's just the tradition. We do our mathematics in proportion. We express our results in percent. That's always the way things have been. People understand percent pretty well because it's used so often. So the bottom 80% control 47% of the wealth. What would the top 20% control? 53% is exactly right. Thanks, Carson. Yeah, they have the rest of it. So there's the big piece of pie. I should have made that as a pie, maybe, huh? Ooh, let's do that. That's how wealth is always distributed. What piece of the pie do you have? All right, so we can't go quite half. So there's the 47% that the least well-off do, and there's the big 53% on my little pie graph. How about that? So there's question 1 from the start to the end. And that's, I guess we really covered 2 of the 3 questions that are going to be on the test. We did a Gini index, and we did a value of a Lorenz curve. Both of those right there on problem 1. So the only thing left to do as far as this new material is concerned to get ready for Thursday's test is to do a comparison between 2 Gini indices. Over 4A, yes we can. 4A goes next. All right, so again, this is going to be pretty much the same thing we did with this part right here, John. So what is L of 0.4? Plug that into the Lorenz curve. And again, someone with a calculator help me out here. 0.0252, is that right? Yep. E to the 3p, there's no way I'm going to be able to get that on my calculator. Minus 0.0252. Whoops. We know what that is. So we have 0.0252 e to the 1.2 minus 0.0252. Do those calculations for me, someone, and I'll start up the sentence. 12%, okay. So notice there's income and there's wealth. The first one, was the first one wealth? Problem 1, I've forgotten already. That's income, yeah. Yeah, wealth, okay. So when we talk about income, we earn income, right? We talk about wealth, we control wealth. We don't earn wealth, that's under our control. Income is something we earn. So watch those 2 verbs. If it's an income Lorenz curve, then the income is earned. If it's a wealth Gini index or wealth Lorenz curve, it's the control. We control the wealth, we earn the income. So there it is, 4A and problem 1 part B, I guess, were pretty much the same question, weren't they? Just worded slightly differently. And I'm going to check my answers. 12% seems right. I have an answer key here. I want to double check it to make sure. Yep, 12% it is, according to my answer key as well. Good. So I guess there's 2 Lorenz curve questions I could ask. I could say, what is L of 0.4? Or I could say, what proportion of the bottom 40% control? Same thing. Sure. Okay. The poorest or the bottom 40% of the population earn 12% of the income. Sorry about that, Anthony. Sure, I'll finish out problem 4. So again, the poorest or the bottom 40% of the population earn 12% of the income is how that would be written. Or the bottom, if you want to say the bottom 40%. Because that's probably the more typical way of saying it. You talk about the top income earners, so I guess the bottom would be the alternate to that. So on we go to finishing out problem 4. Draw a line that represents equal distribution. Well, there it is. So I can use the same drawing on this one that I used on the last one. There's equal distribution. Bottom 0 has 0, the bottom 10 has 10%, the bottom 50 has 50%. That's equal distribution of either wealth or income. Part C, find the area between the equal distribution curve and the Lorenz curve. Okay? So we know there's that one equation. The other one, I think I have memorized now. The other one was y was equal to 0.0252 e to the 3p minus 0.0252. So we want the area between those two. They intersect here at the ordered pair 0, 0, and up here at the ordered pair 1, 1. 0% of the people own 0% of the wealth, 100% of the people earn, I guess it's income, earn 100% of the income. So let's find that area between those two, and as always, we set up our definite integral, take the upper function minus the lower function, p minus 0.0252 E3P minus 0.0252 dp. As always, we want to distribute the minus sign first to make this one go a little more smoothly. 0 to 1, p minus 0.0252 e to the 3p plus 0.0252 dp. So there's the distribution of the minus sign. And now let's go forward into the antiderivatives. I'm going to do the first and the last. Someone out there in the world of YouTube, tell me what this middle antiderivative would be. So that's p. Let's see, I'm going to keep the p. I'm going to raise the power by 1, multiplied by the reciprocal of the new power, 1/2 p. I'll leave a little space for that middle one. There I'm just left with a constant, so the antiderivative of that is 0.0252 times p. If you feel more comfortable using x's all the way across there, have at it. I have my full support, I don't care. So we're missing this middle thing. What's the antiderivative of, I'm going to carry this negative down, what's the antiderivative of 0.0252 e to the 3p? I'm leaving that one for you to calculate out for me. I'm going to finish this out. P equal 1 to p equals 0. Yeah, I like it, 0.0525. No, there's one thing we're missing. That coefficient is off a little bit, so we need the antiderivative of that part right there. Oh, did I make a mistake on that one? Yeah. Yeah, the third part should definitely be plus. How about this second part? What's our antiderivative there? No, it doesn't stay the same. The problem is we have a 3 multiplier there. So if I were to take the derivative of e to the 3p, remember back when we did these using the chain rule? When I would take the derivative of that, I would keep the e to the 3p, but I'd multiply it by the derivative of that function, and the derivative of that function is 3. Doing the antiderivative, I'm going to do the opposite of multiply by 3, so I divide by 3. Yep. So what I'm going to do with this one is keep the coefficient, like we're getting some answers coming in. Hopefully one of them is right. So what I'm going to do with this one is keep the 0.0252. That's going to stay the same. I'm going to keep the e to the 3p. That's going to stay the same. But I'm then going to multiply, or instead of multiplying by 3, I'm going to multiply by 1/3, or dividing that by 3. So there's my coefficient in the middle. I might be able to do this one mentally. Negative 0.0084. Does that look right? Yep. I like that. Oh, I copied the problem wrong. Doggone it. Oh man, I got my 5s and my 2s messed up. That's a 525. That's a 525. Doggone it. All right. 525. 525. Okay, now I'm going to do that division one more time. All right, so let's see, 0.0175. There we go. There's the middle one. All right, so I'll give you a little minute here to catch up on all your work. So that should have been a 0.0525 in each of those instead of a 0.0252. And then Stefania has that one correctly. Yep, so does Matthew. Nice. Yep, yep. So sorry about that. I screwed up pretty badly, didn't I? Too many 5s, or not enough 5s, too many 2s. So now we have it pretty well in hand. We have the antiderivative. We'll plug in a 1. So someone do that calculation for me. All the way across here, plug in the 1. The first two are going to be fairly easy. That one's not going to be too bad either. I'll plug in the 0 because that's a little easier. I can do that mentally. Plugging a 0 here is a 0. Plugging a 0 there is a 0. Plugging in here is a 0. I get e to the 0, which is 1. So this comes out to be a negative 0.175. If you plug in 1, what do you get? Give me 3 decimal places. So when you plug in a 1 across those 3 bits, across our antiderivative, what value do you get? .201. Okay. Right, now to get the area between those two curves, it's going to be this minus this. So 0.201 minus a negative point. God, I got my decimal point in the wrong side. Minus a negative 0.0175. So 0.201 plus, I'm going to round this up, plus 0.175. Add those. Oh man, I'm struggling with my decimal points today. One more time. So 0.201 plus 0.018 would be about a 0.219. So there's the area between those two curves is about a 0.219 rounded. And then part D, we're going to find the Gini index. Remember, the Gini index is just that area doubled. So double that, you get what, a 0.438, I guess? Yep. So the Gini index is 0.438 for that particular population and its income. which looking back is pretty well in line with what the US was back in the 20s. Okay, so one more time, you plug in a 1, you get a 0.201. You plug in a 0, you get negative 0.175. Subtract off the negative, add that together. There's the area between the two, double that. And we have the Gini index. So that wraps up all of question 4, doesn't it? We did it from the beginning to the end, with a little stumble in there along the way. I teach the basic algebra class. I don't know if any of you have taken it, but it's using the ALEKS software. And I walk around my classroom back when we have classes. I walk around and look over at people's shoulders, and I would say probably 30% of the time the question is wrong because the student either copied the problem down wrong on the paper to start, or they copied the answer wrong to the computer at the end. It's one of those things that we're humans and we do this stupid stuff. So my advice is always just make sure you copied right. Next question. Yeah, problem 5 is a great one to look at. There were enough issues on the quiz last time that I'm moderately concerned that this isn't where I'm hoping it's going to be by the time the test rolls around. So I picked off some information. I may try to make it current. I looked at Washington State. I looked, of course, the coronavirus and the infection rate, and lo and behold, had that curve that's written there on your paper. It wasn't an exact fit, but it was a darn close fit. So in the beginning, here's the part where it started getting scary because we were concave up, right? We're getting, not only were we getting more infections, but the rate of infections was going up. Then it sort of stopped growing at quite as much of a rate, hit a peak, and started down. And that's the most data. I think that the last data point I was able to see was April 12, so they were well on the downside of their. I mean, there's still a lot of infections, a lot more infections coming each day, but the rates seem to be dropping fairly good. So if it continues at that rate, it should be down manageable numbers fairly soon. That was Washington State. Now pay really close attention to what the function is. This curve right there, that's the infection rate. And that's in cases per day. Okay. So any number you read off of there, for example, 45 reads out to about 110. So reading over here to 45, you get about 110. 45 days after January 1st, they were about, the infections were about 110 new infections, new confirmed cases that day per day. So it was spreading pretty fast then. Right. So anything that relates with this curve, that's the infection rate. Now, if you look at the units here, that tells you what the area under the curve is. This is days. So if you were to draw a little box out of that plot, it would be 100 cases per day tall. And what is it, 5 days wide? 5 days wide. So 100 cases per day tall times 5 days wide. The area on each of those blocks is 500 new cases. 500 cases diagnosed. That's what the area in each of those blocks under the curve is. So the area under the curve will be the number of new confirmed cases in that whatever period we're looking at. So in this case, we're looking, the definite interval goes from 50 to 55. So right up there is 50, right up there is 55. It's sort of at the, when it was growing the fastest, I concentrated on that. So the area under the curve is what that definite integral is going to give you, and that's going to be the number of new confirmed cases. So if I were to write this out, I suppose I'll take the time and do it slowly. That area under the curve, or the value of that definite integral, the number of new confirmed cases from 50 days past February 1st. And if you wanted to count them out, I suppose you could put a date on that through 55 days. February 1st. Okay. So again, note what that area under the curve measures, and the units just make this so easy. Whatever those units times those units are, that's going to be what's measured under the curve. Okay. So the units just tell you it has to be cases. The other things we've looked at, maybe this was dollars per product times the number of products, and you'll get the dollars underneath. This might have been the number of cars per week times the number of weeks. The number of dollars per hour for that internship times the number of hours, gives us how many dollars. Every time the area under the curve gives you information of these units times those units. In this case, it's the number of cases. Now, on the next part, we're going to take the 1/5 of that. So 1/5 of an interval that's 5 wide. So I'll just write this back up as it was, R of t dt. That part right there is the area under this curve. Now I'm going to flatten that curve out. I'm going to come up with the average value for the function. So this is an average value. Let's see, at 50, it looked like the number of people getting sick each day was about 190. At 55, it looks like it was right about 250. So I would guess somewhere around here at 210, that would be the average. And again, that's just something you can sort of eyeball, right? You want to sort of level out the peak and the valley. You want to make a nice flat line across there so that this rectangle that's underneath here that I have it in green, this green rectangle has exactly the same area as that black shaded area I had before. So we're making this, we're taking this curve that has a big jump in it, and we're leveling it out. I'm going to grab my green pen again because this is sort of has to do with that idea. Okay. So this is going to give us the average value of this function. It's going to give us the average value of this function, and this is the function, right? So here's this. This is the average infection rate. I guess we could put the word new in there if we wanted to, because that was included. The average new infection rate from 50 to 55 days from February 1st. So that verbiage would be the same. But the units here are in cases per day. The black curve here, not the area under the curve, the black curve here is measured in cases per day. We're taking out the hill and the valley, we're replacing that with a nice level line. It's still cases per day. And what would you say that was? I looked ahead, I guess I looked ahead a little bit to the last problem. Oh, somewhere around 210, that's the best I can estimate on that graph. I could give you the equation for that graph, but finding the antiderivative is impossible. It's one of those that doesn't have an antiderivative. There's techniques that you can use to find that area under the curve, but that's as far as we're going to go. Just so, what does it mean? What does the average mean? And of course, there are going to be questions like this on the exam. If you look back on the last quiz, there's an answer key present on that last quiz. You should be able to figure out what you got right and what you got wrong. But just make sure when you're looking about it at an average, you can use this exactly. Just put the word average in there, and the units are the same. You might want to go back, and if you struggle with these at all, go back to your previous activities. We've been doing these, I think, 3 activities in a row now, right? So make sure you go back in your old activities, look up those problems where I had the average rate, make sure you understand how those units work. Because once you do, there's really nothing that can go wrong on these. Well, I guess if I wanted to write this out, maybe I'll just dictate it. That would be, this will represent the average new infection rate from 50 days past February 1st through 55 days past February 1st, measured in new cases per day. Curve you saw was the typical bell curve, which we see in so many different aspects of statistics. The unfortunate thing about the equation of that bell curve is it doesn't have an antiderivative. Here's the function, by the way. This is an A. And there might be some multiplier out front. Time to look at something like that. There's your curve. Taking the derivative of that is easy enough. In fact, I used that one on the solar panel problem on one of the earlier activities. Antiderivative, you're just out of luck trying to find the function that has the derivative of that. One of my specialties, one of my I worked on my master's, one of my areas of specialty was statistics. We have a function whose antiderivative doesn't exist. It makes everything a little bit more of a challenge. Next question. Welcome. My wife, whose job is has a lot of meetings in it, as all her meetings have now been moved to Zoom. Used to travel quite a bit. She's using Zoom constantly, and comics I saw the other day was people and how they look on the Zoom screen. So you have the one where the screen's down, probably an iPhone or iPad or something, where the screen's on the bottom. So the shot that you get is right up someone's nose, cats in the background, and people without clothes on walk by. I guess I'm fortunate I have the nice webcam there, so I appear fairly normal most of the times as far as the presentation here goes. Anything else? Anything else, anybody? Go over 2 and 3, sure. Yeah, well, I can't hurt. Okay, problem 2, might as well go there first. I was able to get a little more information on this one for the last couple of days. I think the last time I looked was 2017. I wanted to update this slide a little bit. So the wealth in the U.S., the Gini wealth, had gone from a 0.787 to a 0.838. I had those 2 data points in the previous iterations of this one, and then a 0.86. So this was the new one. Okay. So those are the Gini indices for wealth in the United States. And you'll notice down a little bit lower, I have the income. So this was what? 89, 13, and 16, yeah. So since these numbers are getting closer and closer to 1, that means going from this year to this year that the wealth was less equally distributed in 13 than it was in 18, and it's even less equally distributed in 16 than it was in 13. So the wealth was less equally distributed in 2013 compared to 1989. Did they go back that far? Yep. It's 1989. And even more equally, and even less equally distributed in 2016. I guess you could go backward and say the wealth was more equally distributed in 2013 than in 2016, which in turn was, and in 89, it was even more equally distributed than it was in 13. But typically, you read time in a forward manner, so I would tend to go from 89 to 2013 to 2016 and phrase it this way. Okay. So there's problem 3 as and again, we don't know what happened in the years between those. We don't know if it jumped up, shot back down again, or if this was a nice steady rise all the way from 18 to 13 to 20 to 2016. If every year the wealth became less and less equally distributed. We don't have enough data to say anything about that. All we have are these 3 data points. And that's all I was able to find on a quick look. Then I looked at the Gini index, and this is again new information. I had a different question there last time. So now let's take a look at the income. The income goes, notice each number is slightly bigger. The 2010 Gini index is less than the 2011, which is less than the 2012. Every single year of all of those 9 years, it looks like the Gini index is growing. So what could I say over that? If there's 9 years, 9-year span, the let's see how to phrase this. The income was less equally distributed as the years went by. Something like that. Less equal distributed. How about each year? That's even better. And then finally, looking at part B, how did the distribution of wealth compare to the distribution of income in the US in 2016? Well, this is almost always the case. I can't think of maybe a stock market crash where the wealth suddenly vanishes from the uber rich. But for the most part, if you have a lot of wealth, you don't. Yeah, well, let me see if I can phrase that a little better. Let me get the answer first. So the wealth number was way bigger than the income number. So the wealth, there's two ways of saying this. The wealth was less equally distributed. And the income in the US in 2016. The counterpoint to that would be that the income was more equally distributed. Than the wealth in the US in 2016. And this sort of should make sense. The income for the bottom 50%, maybe bottom 80%, from what I'm reading these days, most of their disposable income goes to basic living expenses, food, housing, medical stuff. So there's really not a good chance for them to build up a lot of wealth, where the wealthy folks, that's already covered, and they're anything on top of that tends to build their wealth. Okay, so that should take care of pretty much every question that I talked about on that, huh? There's a tendency sometimes for people to say better or worse on that. That's a value judgment. I'm not sure how economics works. I've been told, and I don't even know if this is true, but I've been told that there must be some distribution of income that isn't equal for the economy to run. It's just beyond my comprehension. I'm still trying to figure out how all of this works and why all of this matters, but there it is. There's our two little introductions to economic principles and economic theory today. Anyone have any more questions? Okay, it looks like the quiz opens at 4:45, Carson, so just 5 minutes from now. Again, there'll be two parts. The first one, I'll ask you to find the mathematical expression that's you'd use to find the area between the two curves, and then on the second part, I actually want you to do that exact thing, so find the area on the second part. So if there's nothing else, I'll sign off until tomorrow. Bring your questions regarding tomorrow's exam, Thursday's exam, bring them to me tomorrow on Thursday. We'll see if we can make this one go as well as we did the last one. Yeah, you will need to use the equation editor today. If you've been struggling with that one, contact me. I want to make sure everyone can use it because that's going to be a big part of the exam. There are going to be several. And if there's no way you're going to be able to type in a definite integral without a definite integral sign. That's the equation editor. It's the equation editor that you need to find. And there should be a little button marked f of x. And if you can't find it, okay. I sent out an email to everyone. I sent out screenshots to everyone. I showed everyone exactly where to find it and how to utilize that button. So what you're going to do, Brian, is you're going to log in. You're going to take the test, and in the answer key, there's going to be a whole bunch of things. One of the little buttons is marked like that. Push that button. As long as your pop-up blocker allows, what that's going to do is pop up a little window. And on this window, there are a whole bunch of little tabs, and some of these tabs are mathematical. There's really only two tabs that you're going to need. This first tab has parentheses, it has fractions, it has powers. It has a lot of the basic fundamental understanding algebra things. This last one has definite integrals in it. So those will be the only two buttons that you need to find in this, the only two menu buttons. This first one covers pretty much everything algebraic, and the last one will cover the antiderivative sign. So again, find that. It'll pop up a new window. This will be a brand new window, and you should be able to type in any mathematical expression that you can find. And if you struggle with that, if you can't find it, if you can't make it work today, let's have maybe a Blackboard Collaborate session tomorrow where I can see what your screen looks like, and I can show you exactly what to do. But for the most part, most people were able to, the first time through, were able to use this equation editor. So with this much information, most people were spot on. There were a couple people for whom that didn't show up, but there was a prompt there as to just a control something. You can find that email. I don't remember exactly what it says, but there's a control plus or something that opened up that menu. All right. Again, if you can't find it, Brian, I'll talk to you either later, probably tomorrow. The rest of my day is pretty well scheduled. I have another class coming up. Okay, looks like it'll open in 2 minutes. I'm going to double check the launch on that, and then I will bid you adieu for today. So look again in your quizzes and tests. I'm going to move it to the very top of your quizzes and tests for easy access. It says at 4:45 today it will be available. I'll double check as 4:45 rolls along to make sure you were in. Otherwise, either way, I'm just signing off for today. See you tomorrow.